So this is a question from GATE 2016. So in this we have to discuss the Nyquist stability criterion. So as per the Nyquist stability criterion, it was given as n equal to p minus z, where n is the number of encirclements of critical point. Critical point is -1 plus j0. Number of encirclement of critical point -1 plus j0 in anti-clockwise direction. In anti-clockwise direction. Anti-clockwise direction. P is the number of right hand poles of OLTF. Number of right hand poles of OLTF, and Z is number of right hand poles of closed loop transfer function CLTF. Z is the number of right hand poles of closed loop transfer function CLTF. P is the number of right hand poles of open loop transfer function OLTF, and N is the number of encirclements of critical point in anti-clockwise direction. So it is very important that it is in anti-clockwise direction only. Now the system, closed loop system, will be stable if Z equal to 0, because if there are no poles in the right hand side, then the system is stable. If there is even one pole in the right hand side, then the system will be unstable. So the system will be stable if Z equal to 0. So for Z to be equal to 0, the number n must be equal to p. For stability, the Z must be equal to 0, because for stability there should not be any pole in the right hand side of S plane. So n should be equal to p. It means that the number of encirclements of critical point in anti-clockwise direction must be equal to right hand poles. So this was the question given. A closed loop control system is stable if the Nyquist plot of the corresponding OLTF. So this was the correct option, that the Nyquist plot of the corresponding OLTF should encircle the S point -1 plus j0. This is the critical point in the counterclockwise. Counterclockwise means anti-clockwise. So you can say counterclockwise or anti-clockwise, it is same. So in the counterclockwise direction, as many times as the number of right half S plane poles. So it means that if n is equal to p, then the Nyquist plot of the closed loop system will be stable. So for when n equal to p, then Z equal to 0. So it means that there are no right hand poles in the of closed loop transfer function. So the correct option was this one, option A. Thank you.